The Allegro Security PI application has a decoupling capacitor placement replication feature that allows you to place decoupling capacitors for a device and then replicate that placement for other instances of the same device type. In our design, we have three DDR memory interfaces. The three interfaces have identical memory controllers and memory DIMMs. We used the feasibility editor to create a power integrity constraint set to drive the placement of the decoupling capacitors for our memory controllers and our DDR DIMMs. Here we see the first instance of the memory controller and the memory DIMM, and we have all the capacitors already placed based on the constraints set in our power integrity constraint set. If we scroll over to the right, we see the two other instances of the memory controller and the memory DIMM, and we have not yet placed the decoupling capacitors for those instances. Since the first instance of the memory controller and memory DIMM are already placed with all of their decoupling capacitors also placed based on the power integrity constraint set, we can easily replicate that placement from the first instance to all the other instances in our design. To accommodate the replication, all the memory controllers must reference the same power integrity constraint set, and all the memory DIMMs must reference the same power integrity constraint set as well. If we go to the Constraint Manager, we can check the power integrity constraint set references in the electrical domain by selecting the DCAP template worksheet in the Power Integrity Workbook under the Component folder. Here we see that our memory DIMM XU1 already references the power integrity constraint set, and that will be the source for a decoupling capacitor placement. Similarly, the memory controller U7 has already been assigned to the DDR controller power integrity constraint set, and all of its decoupling capacitors have been placed based on the constraints in that constraint set. To accommodate the placement replication, our memory DIMMs XU2 and XU3 will also have to reference the DDR DIMM power integrity constraint set. And as we can see, when we assign the DIMMs to that power integrity constraint set, the decoupling capacitors are dynamically created for us. So we'll also assign our third DDR DIMM to the DDR DIMM power integrity constraint set, and those capacitors are assigned a reference designator and dynamically created as well. Our next two instances of the memory controller need to be assigned to the DDR controller power integrity constraint set. And just like before, all the capacitors that we need based on the power integrity constraint set are dynamically created for us in our design. They are currently left unplaced. The source for our replication will be the component XU1 and the component U7, and these components have their decoupling capacitors fully placed according to the power integrity constraint set. To replicate coupling capacitor placement from our source components, we simply select Analyze, DCAP Placement Replication from the Allegro Security PI text menu. Allegro Security PI will automatically scan the design to find any power integrity constraint sets that have multiple components assigned to them where the device types are identical and one instance has all the decoupling capacitors placed and the other instances do not. As we can see in the decoupling capacitor placement replication form, our memory controllers U61 and U62 are assigned to the same power integrity constraint set, DDR_controller, as the memory controller U7, which already has all of its decoupling capacitors placed, so we'll be replicating the decoupling capacitor placement from U7 to U61 and U62. Similarly, the memory DIMMs XU2 and XU3 will receive their decoupling capacitor placement from the memory DIMM XU1, which already has all of its decoupling capacitors fully placed. Completing the replication is as simple as picking the Replicate button. After we pick the Replicate button, all the rows in our decoupling capacitor placement replication form have turned green to indicate that the replication was successful. As we can see in the Allegro Security PI canvas, all the capacitors from the power integrity constraint set were placed based on the placement of the first instance of the memory controller and memory DIMM XU1 and U7. In summary, The Allegro Security PI application has a decoupling capacitor placement replication feature that allows you to place decoupling capacitors for a device and then replicate that placement to other instances of the same device type. One of the components in the power integrity constraint set must have all of its decoupling capacitors placed, and the other instances of the same device type must be assigned to the same power integrity constraint set and have none of its decoupling capacitors placed.